Introduction to Derivatives, Basic Derivative Rules. In this video, I'm going to go over some basic derivative rules. I have not explained what they are, but I will do so in a video that follows. If you want to know what a derivative is first, feel free to look ahead and then come back to this. Let's start with some notation. You are familiar with the notation y equals f of x. This is going to represent our function. Similarly, there are two notations that we tend to deal with. One called dy dx, that's how we say that, equals f prime of x. And this is notation for something called the derivative. So what I'm going to do here is I'm just going to give you a function and we're going to find the derivatives. And let's see if you can find a pattern before I tell you how to do it. So let's start with the function y equals c, where c is any constant. Then its derivative is 0. So without explaining why, I'm just telling you what it is. And you're looking for a pattern. If my function is y equals x, its derivative is 1. How about y equals x squared? Well, the derivative of y equals x squared is 2x. We'll try one more. Let's see if you can see the pattern after this one. If the function is y equals x cubed, then the derivative is 3x squared. So see if you can get the derivative of y equals x to the fourth before I write it down. Well, the derivative is 4x cubed. This is something called the power rule. The power rule is for derivatives of y equals x to the n, where n is a number. To find its derivative, we do the following. We bring that power down in front and multiply it, and we subtract 1 to get the new power. That is called the power rule for derivatives. Now we're going to add in something called the constant rule. I'll put the general case in just a bit. But what if instead of having y equals x, we have the function y equals 4x? Well, the derivative is simply 4 times the derivative of x, or 4. What if y equals negative 10x squared? Then its derivative is negative 10 times the derivative of x squared, or negative 20x. So the constant rule is as follows. If I have y equals c times some function, then the derivative is c times the derivative of that function. Basically, we ignore the constant and just multiply it in at the end. Adding that to our power rule, if we have y equals c times x to the n, then its derivative is c times the derivative of x to the n, or nx to the n minus 1. So this one right here is called the constant rule. Now we're going to do sum and addition rules. Sorry, sum and difference rules. What I would like you to do is, after I put the function down, for each of these, I would like you to pause the video, write down what you think the derivative is, and then come back. Hopefully you have taken a guess at the derivative. Well, the derivative of 5x cubed plus 6x to the fourth plus pi squared is 5 times the derivative of x cubed, or 15x squared, plus 6 times the derivative of x to the fourth, or 24x cubed, plus 0. Well, why is the derivative of pi squared 0? Well, that's because pi squared is a number, or a constant, and the derivative of any constant is 0. But the other part, look what happened when we took the derivative of the sum of different functions. We simply took the derivative of each part individually and then added or subtracted them to get the final derivative. That is called the sum and or difference rule. Meaning when we add or subtract functions, we can take the derivative of each part separately. Let's take a look at one that sometimes throws students when I first do it. Once again, I would like you to pause the video and take a guess at what you think the derivative will be. So the derivative of 1x minus 1 over x squared equals negative 1 over x squared plus 2 over x cubed. Did you get that? If you didn't, you might not have used your constant and power rule correctly. I will rewrite it here for us so we can see it. That is, I know this rule, and then of course the sum and difference rule, that the derivative of c times x to the n gives me c times nx to the n minus 1. This is all I'm allowed to use. I can't make up my own rules when I'm doing this. So how do I get this line? Well, what you need to do is rewrite your function into a form that looks like something I know, so that I can take its derivative, which says, looking at the first part, bring the power down, multiply it, subtract 1 to get to the new power, and then I'll subtract. And the back part, I will bring the power down, subtract 1 to get to the new power. And if I were to clear this up a bit, I would end up with negative 1 over x squared plus 2 over x cubed. Let's take a look at one last one. What if my function is the square root of x plus the cube root of x? Just like this one above, we're going to want to rewrite our function into a form that I can use. That is, some number, in this case 1, times x to a power. And I need to do it for both of these. Then I can get the derivative using my power rule, which gives me 1/2, bringing the power down, subtracting 1 to get to the new power, plus 1/3, bringing the power down, subtracting 1 to get to the new power. Now this is fine as is, but I will often write this first part as 1/2 root x. And I could rewrite this back part, but I rarely use radicals unless I just have a square root.